This is our second presentation on the introduction to 2D parameters for surface roughness characterization. We have the screen in front of us, which was left from the previous presentation, where we have some AFM data loaded into the BEX software, the 2D section corresponding to the line in the image shown. And we described an introduction to the Gaussian filter, the blue line here, with the red line as the raw data in the previous presentation. So a bit more detail on this. Let's start by zooming the image here so we get a bit more detail of the cross-section. Let's move the cross-section to a different point, so let's move it to here. That will have redrawn the 2D cross-section below, so we have a slightly different pattern to the pattern that we had in the previous talk. Let's just go back and let's have a quick look at the effect of the Gaussian filter on the data. So we started bearing in mind that this data set is 40 microns long, as shown in the 2D section beneath, with 40 microns here as the length of the data. We selected a filter of 2.5 microns in the previous talk, and this is the blue line is the filter that corresponds to that. And what you see is it maps the basic profile of the surface as shown. I'm just going to click on this window and let's see the effect of the Gaussian filter. So I've put this to the smallest value that we have, which is 8 nanometers. And you can see at that scale the Gaussian filter is identical to the raw data. Let's switch off. So this is now 25 nanometers. Not much of a difference. In fact, we'll probably see more of a difference if we now click the roughness, which, if you remember, is the difference between the two. Let's go back. This is 25 nanometers. Let's go up to 80. Keep an eye on the images in the lower screen. And now you start to see something. You see that the roughness is appearing now because the blue line is slightly different from the red line. Let's carry on with this. So this is 0.8 of a micron. You see the blue line is not quite matching the identical positions of the red points, and there's more roughness, and so on. Let's do this. Just keep an eye on the lower image as I rotate change the scale of the filter. So this is 2.5, which is where we were. This is 8 microns, and now you can see the effect of the filter on the roughness value, because actually the filter is cutting off the two outer regions of the raw data, so we're losing 8 microns at the front of the data, 8 microns at the end of the line. Bearing in mind it's only a 40 micron line, if we change this to the next value, going up to the cutoff in the top left here, this is now 25. Oh, 25, you lose all of the data. So actually the largest value you could have for the cutoff is 8 microns, and then you get the basic roughness is the difference again between the red and the blue lines. Now, trying to explain the Gaussian filter, I talked to my computer designer who worked on the software, and he went into some mathematics about the convolution matrix. None of that's really going to help you. I think as a user, a non-expert or a non-mathematician, the best way of seeing this is actually just to see the effect of the filter on the red line. And I think you can see that intuitively as I just switch back through these. Let's go down the scale again. You see it, the smaller the cutoff, the closer it matches the original data. Which one you use for a particular application will depend on all kinds of all kinds of reasons for that, and that will depend on the case study, and we'll go into that in much more detail in case studies which will follow on this, where we will look at particular applications and then we will choose particular filter characteristics. Just finally, just focusing on the parameter window here on the left, we've got the RA values which correspond to the green line, we've got the WA values which correspond to the blue line, and we've got the PA values which correspond to the profile, the original raw data. So just to repeat that, R is the roughness, the difference between the raw data and the waviness, W is clearly for waviness, and P is for the original profile. These are standard terms used in all two-dimensional roughness characterizations.